properties of eigenvalues and eigenvectors. So one of the property is every a square matrix a square matrix and its transpose have same set of eigenvalues. So that means if you have a matrix A equal to 1 2 0 3, then and A transpose is equal to 1 0 2 3. So if when you find out eigenvalues, what are eigenvalues of A? Okay, let us use a few. You know how to find out eigenvalues and eigenvectors of a matrix. So let us do uh, eigenvalues, eigen eigenvalues, and calculated. Calculator 2 by 2. So let us uh, calculate by using uh, some software. If you type, okay, what are the elements? So what is first element here? 1 2 0 3, right? 1 2 0 3. So now I am calculating eigenvalue, computing eigenvalues. So you know how to find out eigenvalues. So I'm just using a calculator. So what are the eigenvalues? 3 and 1. Okay. So A has eigenvalues 3 and 1. So here lambda equal to 3 1. Now we have to check whether what will be the eigenvalues of its transpose. So what is transpose of this? 1 0 2 3. 1 0 2 3. So I am calculating this. So what are the eigenvalues here? That is also you check. If you calculate this, the eigenvalues is again 1 1 and 3. So here also eigenvalues are 1 and 3. So that means if you have a square matrix A and A transpose have same set of eigenvalues. Okay. Now second property is eigenvalues of a triangular matrix are the same as its diagonal element. What do you mean by triangular matrix? Anybody? Triangular matrix. There are two type of triangular matrix. One is upper triangular
And the other triangle.
and the lower triangular. Now tell me what is this a triangular matrix? A.
Yes.
And what type of uh, triangular matrix is this?
Upper triangle.
Element is 0. Now what are the eigenvalues? By property, eigenvalues are same as diagonal elements. So what are the eigenvalues? We already calculated eigenvalue 3 and 1. So what is that? They are diagonal elements. So eigenvalues of a triangular matrix are same as its diagonal element. Similarly, eigenvalues of a diagonal matrix is same as its diagonal elements of the matrix. Okay. If matrix is diagonal, then eigenvalues are its diagonal elements. Now there is very important property. Sum of eigenvalues of A is equal to sum of the elements of diagonal. That means trace of A. So the important property is sum of eigenvalues of A is equal to trace of that matrix. So sum of eigenvalues of A is trace of that matrix. And what is next? Check here. What are the sum of eigenvalues? Lambda equal to 1 and 3. So sum of eigenvalues is 1 plus 3, 4. And what is trace here? Trace is also 4. Now, next property. Product of eigenvalues of A is equal to the determinant of A. Product of eigenvalues of A is equal to determinant of A. That is product of eigenvalues of A is equal to determinant of. So what is determinant of this matrix? So let us calculate. 1, 2, 0, 3. What is determinant of this? Determinant of this matrix?
3,
What are the eigenvalues?
1 and
1 and 3. So its product is
3.
1 and 3. Product is 3, right? 1 into 3, 3. And that is equal to determinant of, that is equal to determinant of. So that is product of eigenvalues of A is equal to determinant of A. So if you want to calculate eigenvalue of a values of a triangular matrix, then it's very easy. You just write down the diagonal elements. Okay. So some cases you don't need to even calculate a characteristic equation. Just you have to use these properties. Okay. Now another property is lambda is an eigenvalue of A, then lambda minus k is an eigenvalue of a minus ik. Okay, so here ki, a minus ki for any scalar k. So lambda is an eigenvalue of a, then lambda minus k is an eigenvalue of a minus k. But it is not true that if lambda 1 is an eigenvalue of a and lambda 2 eigenvalue of a, this doesn't imply lambda 1 minus lambda 2 is eigenvalue of a minus 2. So this is not, this is not true in general. A lambda 1 is eigenvalue of a, lambda 2 is eigenvalue of b. That doesn't imply lambda 1 minus lambda 2 is eigenvalue of a minus b, or lambda 1 plus lambda 2 is eigenvalue of a. So that is not true. Now another property, if a lambda is an eigenvalue of a, then lambda power m is an eigenvalue of a power m. That is, lambda is eigenvalue of a, then eigenvalues of a power m is lambda power m. The next property, if lambda not equal to 0 is an eigenvalue of a, then 1 by lambda is an eigenvalue of a inverse. So if you want to find out eigenvalue of a inverse, if you know eigenvalue of a, then 1 by lambda is eigenvalue of a. And last property, lambda not equal to 0 is an eigenvalue of a, then Determinant of A divided by lambda is an eigenvalue adjoint of A. So go through these properties. You have to study these properties so that we can do few problems. Is it clear? Any doubt? Any doubt? Clear, right?
Yeah.
Okay, tell me if you have any doubt, you can ask me. So now you write down this question. Q is an eigenvalue of A of this matrix without using characteristic equation. That is, you can use characteristic equation. Find the other two eigenvalues and also find eigenvalues of A cube minus A inverse A transpose 5A A minus 3A and adjoint. This is university question. July 2007, July 17, 2019. Okay, so let us do this problem. So given lambda equal to 2. Now tell me how to find out the other two eigenvalues. So one eigenvalue is given 2. And let lambda 1 and lambda 2 be two other eigenvalues of A. Then then we have to then find first we have to find lambda 1 and lambda. Now tell me what is the procedure. You cannot use characteristic equation. You can. Okay, tell me. What are the properties?
Eigenvalues is equal to trace.
Okay, sum of eigenvalues is equal to trace. That means 2 plus lambda 1 plus lambda 2 is equal to what is trace here?
11.
11. Sum of the diagonal. And the second property, you calculate what is the determinant of 2 into lambda 1 into. What is determinant? Just calculate and tell me. You can use calculator for calculating determinant or otherwise you can easily find using formula. So anybody got determinant? Is it 36? Anybody got determinant?
Yes, sir.
36.
36.
So from here you have 2 plus lambda 1 plus lambda 2 is equal to 11. Therefore lambda 1 plus lambda 2 is equal to 9, right? Now from here lambda 1 into lambda 2 is equal to 80. So the product of two numbers is 18 and sum of two numbers is 9. Then how to calculate? Then what is lambda 1 and lambda 2?
6 and 3.
6 and 3. Good. 6 and so what are the eigenvalues of A? Eigenvalues of A are 2, 3, 6. Okay. 2, 3, 6. Is it clear? Anybody have any doubt? It's all clear, right? Now, next question is solution. We have to find out eigenvalues of A cube. Therefore, eigenvalues of A cube are what are the eigenvalues? Eigenvalues of A is 2, 3, 6. Then A cube by
2
property
cube, 3 cube,
2 cube, 3 cube, 6
3
cube.
cube, 6.
cube, 3 cube, 6. Now, what are the eigenvalues of A inverse A inverse 2,
1 by
3.
2, 1 by 3,
1 by 2, 1 by 3, 1 by.
1 by 6.
So next what is eigenvalue of A transpose? A and A transpose have same eigenvalues.
Same again.
So that is 2, 3, 6. Next question, find eigenvalues of 5A. What is eigenvalues of 5A? 5A. Constant times A. So tell me what is eigenvalues of 5A? Anybody? Eigenvalues of 5, you just multiply eigenvalues of A with the 5. Okay?
5, 15, 30.
10, 15.
10, 15, 30.
30.
So eigenvalue of 5A is 10, 15, 30. Now what is eigenvalues of A minus 3I?
-1.
Minus 1,
0. 3.
0, 0, 3, right? Or 3, 0. Minus 1, 0. Now tell me what is eigenvalue of adjoint of A. Determinant we know that 36, right? So adjoint of A by property
18.
18,
4.
4,
6.
6. 18, 4, 6. 18. Determinant of 36. 36 by first 2. Then 18. Then 3 is 12, right? 4 or no?
12.
12. 12, right? And if you divide it by 6, it is 6. Is it clear? So determinant adjoint of A. Eigenvalue of adjoint of A is determinant of A by family. Okay. It's easy, right? Anybody have any doubt? Doubt? Now tell me what are the eigenvalues of this matrix. A is equal to 300540061. What are the
3,
eigenvalues? 3, 4, 1.
3. 1.
They are the eigenvalues. So is it clear?
Yes.
Anybody have any doubt?